So I'm going to talk about a straight line graph. So a straight line graph is characterized by number one. Let's talk about straight line graphs. So number one, y is equals to ax plus q. Number two, f of x is equals to mx plus c. And right. So in this case, a or m is the gradient, right? So this is the gradient. And then q or c is the y-intercept. So what is the gradient or the y-intercept? When you're talking about the gradient or the y-intercept, for example, you have a line, you have a point, and then our line goes like this, and then this is our point A. Let's say this is our point A, and this is our point B, right? So let's say this is 1 and this is 7. I'm just assuming, I'm not really drawing it up to scale. So this is 1 and 7, and then this is -1 here, negative, let's say -2, and this is 8. So this point will be 8 and -2. So remember, we always start from the x-axis. When you are stating a point, you always start with the x-axis and the y-axis. Always x and y, right? So for you to get the gradient, what is a gradient? When you extend this whole thing to be a triangle, it should give us a 90-degree angle there. So the gradient is what we get when we extend this, and then we get a 90, and there is an angle here, and then there is an angle there. It's all about the Pythagoras theorem, but you don't need to know much about it. What you need to know is to be able to get the gradient. How do we get the gradient? Y is equals to x2 y2 minus y1 over x2 minus x1. So for the gradient, this point, any point can actually be y1, y2, any point, any one that you choose, it can actually be y2 or y1. So let's say we say this is our y2, so we're going to substitute. We say -2 minus 7 all over x2, which is 8 minus 1. So it's going to be -9 divided by 8 minus 1, which is what? 7. So our gradient will be this. Why is it a negative gradient? Think about it. Why are we saying this gradient is negative? Is it because we just calculated it like that, or I made a mistake? The reason why we're saying it's a negative gradient, remember, when something is going up like that, it's a positive gradient. Why? Because there is a steep that is going up like that. But if something is going down like this, now we're talking about negative gradient. Why? Because it's going down like that. And if you look at it in physics, like for example, if you're doing physics, when you have something like this, we're saying that this thing is actually decelerating. But when you're saying something is going up like that, we are saying that that thing is actually what? Accelerating, going up like that. But if it's, then it's deceleration, it's slanting down, it's going downwards. Are we together there? Okay, so many people say that when I'm talking, I'm just saying, are we together? Do you understand? All right, so if you get me, then we are good to go. So there is a way that we are supposed to define our linear functions. How do our linear functions look when, for example, you are drawing a graph? You are drawing your graph, and you have to know how your graph looks like. For example, this one doesn't, it's not showing. Okay, let me use this one. All right, so if I'm going to be drawing my graph, right, and then I draw my graph like this is my y and this is my x, like that, right? So when it's going like that, a is less than 0 and the gradient is less than 0. The gradient that we are talking about is this one. So if it's slanting like that, then a is less than 0 and q is also less than 0, right? What if the gradient is equal to 0? There, a is equal to 0, a is equal to 0, and then q is equal to y is equals to q. So our graph is going to look like that. So this will be our x. And then when a is greater than 0 and q is greater than 0, it looks like that. And then when a is undefined and there is no q value, then it's going to look like that. A is undefined and q has no value. There is no q value, right? So I hope you do understand on this part of the straight line graphs. If you have any questions, let me know in the comments. Bye.